added. Since 2007, the game called checkers has been mathematically solved. If both players play perfectly, the game ultimately ends in a draw, which I find very disappointing because I really like checkers. So I did what every movie industry does when they want to make a topic sound interesting. I added the word quantum in front of it, and now we have quantum checkers. So this is what the game looks like. It just looks like ordinary checkers, and you can also play it like ordinary checkers. Here, if I move these pieces, you can see that if you can capture a piece, you have to capture. And the game just works as you would expect it to work. However, since it's quantum checkers, the pieces have the option to make a quantum step. What happens in that case is you can press on a piece and then click on it again, and then it has a 50-50 chance to either go to the left or go to the right. So it's in these positions at the same time. And the new rule with this is that if there's a chance that you can capture a piece, you have to capture that piece. So in this case, for this black piece, there is a 50-50 chance that it is able to capture this piece. Well, so let's try to capture it. So we just now try to make a capture move, and what you can see is that this black piece now split into two, because there's the chance that the white piece moved to the left, and well, if it moved to the left, then the piece wasn't right here and it wasn't able to capture the piece. But there's also a 50-50 chance that it went to the right and that we just successfully captured the piece. So now it's the white player's turn, and if you click on this piece right here, then you can see that from the perspective of this piece, this black piece is right here, because if this white piece is right here, the black piece will be right here, but if the white piece was right here, then the black piece is right here. So the funny thing is that from this white piece's perspective, this black piece doesn't exist, and we can just continue on with our journey as if nothing has happened. Well, black can do the same right here, and then we can capture this piece. And now what you can see is that we have entanglement in a certain way, because if this piece is right here, well, then this piece would have moved, but if it doesn't, well, it doesn't exist. And this way we can have a really interesting encounter that if this piece exists, this piece also exists, but this one doesn't. And this is how you get a lot of entanglement on the board, and you can see how this game can get really complex very quickly. So let's take a look at a few examples. This is one of the real nightmares that you can have in a game of checkers, because at this point, if you're the white player, it doesn't really matter what you do, you will lose. For example, if you go to the left, then your piece is getting captured. If you're going to the right, your piece is being captured. But in quantum chess, you at least have a chance to survive. Here, take a look. If we quantum move our piece, then there's a 50% chance that it's on the left, there's a 50% that it's on the right, and the black piece will have to choose, does it want to capture the left piece or the right piece? So let's say it captures the right piece. In that case, this piece still exists and it manages to reach the end to become a double piece. So making a quantum step has the advantage that in some cases there is a chance that you will make it beyond certain points. And there are other strategic ways to deal with quantum moves. What I really like to do is just to entangle my pieces as much as possible and really mess up the board that way. In my opinion, it looks very cool and also very intimidating. However, most of the time it isn't really that effective. That's how the game of quantum checkers works. I hope you'll have a little bit of fun with it, and feel free to check it out on quantum.northstar.me. I'll add a link in the description. Thank you for watching, and I'll see you again in 3 months.